So let's take a look at this coordinate geometry of the line question from the 2014 Leaving Cert Ordinary Level Paper 2. It's question 4 and we're given the three vertices of a triangle. A minus 9, 3, B minus 4, 3 and C 4, 10. And we're asked to find the distance from A to B. So we can see by inspection that the distance from minus 9, 3 to minus 4, 3 is 5 units, the difference in length between minus 9 and minus 4. We can measure horizontal and vertical distances by just subtracting the numbers on the x-axis or the y-axis respectively. We're going to confirm the answer by using the distance formula in our maths tables. So we label the points minus 9, 3, x1, y1 and minus 4, 3, x2, y2 and we sub them into the distance formula. The distance is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. Subbing in the numbers for x1, y1, x2 and y2, we have that the distance from A to B is equal to the root of minus 4 minus 9 squared plus 3 minus 3 squared. Minus 4 minus 9 is equal to minus 4 plus 9, which is 5. And so we have AB is equal to the root of 5 squared plus 3 minus 3 is 0 squared. 5 squared is 25, and so AB is the root of 25. So the distance from A to B is 5 units. Part 2 of the question asks us to find the area of this triangle ABC. There is a coordinate geometry formula for finding the area of a triangle, but because this triangle is right angled, we can just use half the base by the perpendicular height. In our triangle, the base is 5 units as we found in part 1, and the height is the difference between 3 and 10, which is 7 units. Plugging these numbers into the formula, we have that the area is equal to half of 5 by 7, and so the area is equal to 17.5 units squared. In B part 1 of the question, we're told that x is the point 2 minus 4 and y is the point 2, 1. And we're asked to draw a diagram of a triangle XYZ which is congruent to the triangle ABC that we have already. So to put in the points x and y, x is 2 minus 4 and y is 2, 1, we can see that the vertical distance between minus 4 and 1, the distance from x to y, is 5 units. So this is the same as the base of our original triangle. If we're going to draw a triangle that's congruent to triangle ABC, all of the sides and angles must be the same. So we want to draw now a line that's 7 units in length. So starting at the point y, 2, 1, we're going to draw a line that's 7 units in length horizontally out to the left. We're going to mark this point as z, which is the point minus 5, 1. To complete the triangle, we're going to join z back to x. So this triangle now is a triangle which is congruent or exactly the same as the triangle ABC. Part 2 of the question then asks us to write down the coordinates of z, which we've already done, minus 5, 1, and explain why the triangle XYZ is congruent to the triangle ABC. For congruency, we have to meet one of the following conditions. Either all the sides in the two triangles are equal, 2 of the sides and 1 of the angles are equal in measure, or 2 of the angles and 1 of the sides are equal. So if we take our two triangles, we can see that XY is equal to AB. They're both of length 5 units. YZ is equal to BC. They're both of length 7 units. And finally, angle XYZ and angle ABC are equal because they're both 90 degrees. So we meet one of the conditions for congruency, that 2 of the sides and an angle are the same, side, angle, side, and therefore triangle XYZ is congruent to triangle ABC.